All right, so the same process will go for the sine, sum, and difference identities. These are different identities, right? So again, always refer to your reference sheet that will be provided. So you don't memorize these, because even if you try to memorize them, we usually mess up on this plus and minus business. So once again, we have this sine of 165 degrees. We just want to figure out how we can break up 165 degrees to be two things that are on our unit circle. So it is up to you if you want to add them or subtract them. I'm just going to go ahead and add, because I think one, and sometimes it forces you to only use one. But one thing that really stands out to me is I could just do sine of 120 degrees plus 45 degrees. An order doesn't matter because the identity will take care of it in the formula. All right, so I chose to do sum, so I'm going to focus my attention here. So what this formula says is, I'm going to move here so I have enough space, even though our equal signs should line up vertically. I have sine of alpha, which is 120 degrees, cosine of beta, 45, plus cosine of 120 degrees times sine of 45 degrees. Rely, well, hopefully it's memorized, but I'm going to use it as a teaching tool. I'm going to focus my attention on the 2 degrees I chose, which is 120 and 45. Sine of 120, root 3 over 2, times cosine of 45, root 2 over 2, plus sine of 120, oh, forgive me, cosine of 120, negative 1/2. And then sine of 45, root 2 over 2. Root 3 times root 2 is root 6 over 4. The negative 1 times root 2 is a negative root 2 over 4. So you could leave it like that, or you can put it over the same denominator, and that's the exact value. So if you went to your calculator and it said sine of 165 degrees, it would give you a decimal, which is approximately what this exact radical would equal. All right, so here's the one that's a little bit more challenging, right? Because they're radians, it's fractions. But you just want to think about how you could break it up so something would reduce to being on your unit circle. So, if I did 18 pi over 12 plus pi over 12, that's not going to help me because there's no pi over 12. So you just start playing around with it. I'm going to choose just to do the sum again. So I'm going to choose to do 16 pi over 12 plus 3 pi over 12. Because again, if I add those together, I'll get 19 pi over 12. Well, let's go ahead and just lack of space. Get rid of that. I'm going to put my equal signs here so I don't run out of space. So now I'm going to reduce those fractions. Well, 16 pi over 12 reduces to 4 pi over 3. And 3 pi over 12 reduces to pi over 4. I'm always going to refer to that beautiful identity that will be given to me. So it looks like I do sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So once again, I'm going to go to a clean space so we can look at this. I'm going to get rid of this, and then I'm going to say, okay, I'm going to focus on 4 pi over 3, which is here, and pi over 4. Sine of 4 pi over 3, negative root 3 over 2. Cosine of pi over 4, root 2 over 2. Cosine of 4 pi over 3, negative 1/2. And then sine of pi over 4, root 2 over 2. Multiply straight across, we get negative root 6 over 4 minus root 2 over 4. So you'll see a lot of these are very similar, give or take a plus or minus. So you can leave it like that, or you put it over the same denominator. And we should stick to what I mentioned earlier. It'd be awesome if at the very end you would say sine of 19 pi over 12 equals this. All right, let's go back to D. So let me zoom out a little bit. So that's sine of pi over 2 minus theta. So that is, I'm going to use this lovely identity now because it's the difference one. So that says do sine of alpha, which is sine of pi over 2, times cosine of beta, which is theta, minus cosine of alpha, pi over 2, times sine of theta. Sine of pi over 2 is 1, times that by cosine theta. Cosine pi over 2 is 0. And what do you know? So cool. We get that cofunction business again, which totally makes sense because sine of pi over 2 minus an angle, right? Anything that's complementary, that will end up being cosine of that value. So again, I'll say, like I said in the last video, like, you know, sine of 30 degrees is the same thing as cosine of 60 degrees. And those are the cofunctions. And this is just another way to prove it. And then if I was being really great, I would take one step. I should have gave us more space on these notes. State what you found. So it's like proving your identities piece. Okay, one more example with this video is here it is given to you in the opposite way. So I've shown you examples where this is what's given and we have to find this piece. Well, now in example 3, this is what is given and we have to work backwards. So if we have cosine, you know, we'll label this alpha, we'll label this beta. So what formula matches cosine alpha times cosine beta minus cosine alpha times, sine alpha times sine beta? Well, it doesn't look like either of these. So I'm going to, again, look at always my reference sheet, but I'll look here because it's provided. And this looks like this identity, right? Because, oh, no, it doesn't. It looks like the reason I know it doesn't is because in the middle, there's a plus, wherein for us, between these things is a minus. So I want to look here, right? It looks really darn similar because I have cosine of 40 degrees times cosine of 80. And then I have a minus sine of 40 degrees times sine of 80 degrees. All right, so now what I can do is move backwards. I know what my alpha is. I know what my beta is. It's given to me. So I'm going to go back. And this would equal cosine of 40 degrees plus 80 degrees. And what is cosine of 40 degrees? Or sorry, 40 degrees plus 80 degrees, because I don't know what cosine of 40 degrees is. So that's why I couldn't evaluate it using my unit circle. But now I can add these two angles together. I get 120 degrees. And that is good news for me because if I look at 120 degrees, which is right here, my cosine is -1/2. So what you want to do is just make sure when you're looking, don't make the mistake I originally made, that this entire piece looks exactly like one of these. And that's when you can move backwards and go to one of them. All right, see you in the next video.